Hey, what is up guys? Welcome to another video. In this video I'll be talking about composite and inverse functions. Now before we get into this video, I'm assuming you know about functions, you know the rules of functions, and you're comfortable with using functions already. So I'm not going to go into what functions are or the rules of functions. I'm just going to get straight into composite functions first and then go over some inverse function problems. Okay, so let's start on composite functions. So if we take two functions like f, the function f, and we say that equals 2x plus 1, and then we have another function g, and that equals x squared plus, a composite function would be combining these two functions. So I could say, I might want to find the function f of g. And so what I have to do here is to put the function g into the function f. So I'm adding two functions together basically, or combining two functions, so we call those composite functions. And here we have, so the question is asking find f of g. Now remember this x here in this function is the input. And so if I'm saying the input is another function, I need to put that function x squared plus 1 into the space where the input needs to go. So this is going to look like 2 times x squared plus 1, and then I have that plus 1 on the end. So I've taken this function and inputted it where the x is in this function here. And then I can just go ahead and solve this. So firstly expand the brackets. This is going to be 2x squared plus 2 plus 1. And then simplify 2x squared plus 3. So f of g is going to be 2x squared plus 3. And we could also do this the other way around. So we could ask for the function of g of f, and you'll notice something about these two functions in a minute. So if we find the function g of f, we need to take the function f and input it into the function g. So where this x is, consider this kind of like an empty box or a space where we can put things in. We take this function 2x plus 1 and put it into here. So we need to square 2x plus 1 and add 1. And then we can go ahead and solve this. So expand those brackets out and multiply, and we get 2x times 2x, that's 4x squared, plus 4x plus 1 and plus 1 again. And then simplify, so 4x squared plus 4x plus 2. Okay, so now you notice that g of f is not the same as f of g. So that's a common element of functions, of composite functions, is that the order matters. So if we take f of g, it's not going to be equal to g of f. And so that's the basics of composite functions, and then questions can get more complicated when you combine different elements of algebra. So we could get a question saying something like solve 2f of g equals g of f. So here we need to take the solutions to these functions, make them equal, and then solve the equation. So I have f of g, that's 2x squared plus 3. So I need to multiply that by 2. So it's going to be 2 times 2x plus 3. And I also have g of f, which is 4x squared plus 4x plus 2. So that's on the right hand side. And now I have my equation. I can go ahead and solve this for x. So expand these brackets out first. This is going to be 4x squared plus 6 equals 4x squared plus 4x plus 2. We have 4x squared on both sides, so if we subtract them, they will cancel out. And then perhaps you could subtract 2 from the left hand side, so we get 4 equal to 4x. and then divide by 4, so what we're going to end up with is x equal to 1. And if you want to check that, substitute that into the original equation and you would find that that's the answer. Okay, so from this basic element of combining two functions, inputting one function into another function, you can get more complicated looking questions. And this is nothing you probably haven't done before, which is just solving an equation with one unknown. But I guess the new element is this new notation of using function notation. So it adds just a slight level of difficulty to the question. Okay, so now I want to go on and talk about inverse functions. So you can be given a function such as f of x, or f equals 1 over x, and then you might want to find the inverse of that. So we typically write that as f to the minus 1, which stands for f inverse. And so the first thing we need to do is we say that let f equal y, because the idea of an inverse is that we can take the output and find the input. Now when we're talking about a typical function, that gives us the output given any input, and what the inverse function does is gives us the input given any output. So first thing we do is we let f of x equal y, in other words the output. So we can say y equals 1 on x and rearrange to get x by itself. So in this case we'll multiply this side by x, so xy equals 1, and then divide by y, so x equals 1 on y. And now what this equation is doing is saying if we input y, we will get x. In other words, if we input what we originally called the output, we will get the input. So that's the idea of an inverse function. And so now we change the letters, so the output becomes the input. In other words, the output becomes x. So we call this f inverse, f to the minus 1, and the y becomes the input, so this is going to be 1 on x. So this gives us the input of the original function given any output. So you can see it's just the opposite or the inverse of the original function. I hope that makes sense. So let's just do one other example of this. So you might be given a function like 2x minus 4, and you're asked to find the inverse. So remember, the first step is to let f equal y, and then say y equals 2x minus 4, and then rearrange for x. So add 4 to the left hand side, so this is going to be y plus 4 equals 2x, and then divide by 2, so y plus 4 divided by 2 equals x, and so x equals y plus 4 divided by 2. And now remember that y, or that output, becomes the input, and we call this the inverse function. So we can say f inverse equals x plus 4 divided by 2. And that's pretty much the method you can use in all cases when you're asked for an inverse function. So as long as you practice that method enough and you can understand it and remember how to do it, then you'll be fine with questions on inverse functions. And then they can just get slightly more difficult. So you can get questions such as this one, where you're given f, which is 4x plus 5, and they ask you to prove that f of f inverse equals x. So this is asking you to first find the inverse function and then input that into the original function. So the first thing we have to do is to find the inverse function, and remember that means letting f equal y, and so we can say y equals 4x plus 5, and then rearrange to get x by itself, so this is going to be y minus 5 on 4 equals x, so subtract that 5, divide by 4, and then therefore f inverse equals x minus 5 divided by 4. And now we want f of f inverse. So we take this function and input that into the original function. So f of f inverse, and we can change that input to be x minus 5 on 4. And this is going to be 4 times x minus 5 on 4 plus 5. And now we just need to simplify this right hand side. So 4 multiplied by this fraction, well, the 4 divided by 4 is just 1, so we can cancel those 4's out. And on the next line, we are just left with x minus 5 plus 5. Well, minus 5 plus 5, that's 0. So we're just left with x. And so therefore we can say f of f inverse equals x. So we've proven what they've asked us to prove. And lastly, you can get questions such as this one. So it might say find g given g equals mx plus c and the function f equals 2x plus 3 and f of g equals 6x plus 7. Okay, so this is saying that the function g must be a straight line. Remember, this is the general equation of a straight line, mx plus c. And we're given a new function, f, and we're told that when we input the function g into f, we get 6x plus 7. So in order to find the function g, we can input this general equation into f. So we can say that f of g will be 2 times mx plus c plus 3. So I've taken this here and inputted it into f of x, where the x is. Right, so I've got 2 times mx plus c plus 3. And then start to simplify this. So this is going to be 2mx plus 2c plus 3. And we're also told that f of g equals 6x plus 7. So I have an expression here for f of g, which I can make equivalent to this expression up here. Now in this expression, 2mx will be equivalent to 6x. So therefore I can say that 2m equals 6. Right? So this coefficient of x must equal this coefficient of x, because these are the same functions, f of g. So that allows me to say that m equals 3. Also, 2c plus 3 must equal 7. So that allows me to solve for c. So 2c equals 4. So c must equal 2. And so I have m, I have c. So therefore I can say that g will equal 3x plus 2 for my final answer. Okay, so that are the general types of questions you get in terms of composite and inverse functions. I'll leave some practice problems in the description. In GCSEs, if you understand these basics of inputting a function into another function and this method of finding inverse functions, then you should be fine with this topic. Let me know if you have any further questions. If I missed anything out, let me know in the comments. Leave a like if you appreciated this video, and I'll see you in the next one. Bye for now.